Hello, everyone. I'm Chris Brewer, Customer Development Manager for Lean Scheduling International. We're so glad that you've taken time out of your schedule today to join us on this webinar, which is Advanced Planning and Scheduling for the Packaging Industry. We're set for 1 hour today, and what we're going to do, we're going to walk through Opcenter APS, which is formerly known as Preactor Advanced Planning and Scheduling. We're going to show you common planning and scheduling headaches that those of you in packaging manufacturing face day to day, whether you're in flexible or rigid. I'll be your moderator today, and we're going to pause periodically to give you the chance, to ask questions. You can do that by using the Q&A button at the bottom of your screen, or you can send a chat through the chat window, which is next to the Q&A button. Alongside me today is Hans Albright and Fraser Bonnet. Hans has a wealth of manufacturing and consulting experience. He's got 30 years of experience in manufacturing systems, and he spent the last 20 years both selling and implementing APS and ERP solutions. He is now our Vice President of Sales and Marketing here at LSI. And then we've got Fraser Bonnet, and there's a good chance that Fraser has more experience with Opcenter APS than anybody in North America. After he served 10 years in the United States Air Force as a program manager, and then he spent a few years working with SCADA software at Raytheon. He spent the last 23 years delivering Opcenter APS. But to make sure that we make good use of our time today, I'm going to go ahead and turn it over to Hans. So Hans, if you're ready, let's roll.
Great. Just a real quick confirmation that everyone can hear me okay and see my screen.
Yes, to both.
Absolutely. Yep.
Excellent. Okay. Well, first of all, thanks everyone for coming. Welcome from your, whether you're in a boardroom, in an office somewhere, in a home office, or at your kitchen table. We're really glad to have you with us today. And it's our hope that you will see some things today that will maybe inspire some questions, and you can get back to us and try, hope to learn more. So let's go ahead and get started. So today we're going to talk about basically I'm going to run through a set of introductory slides where I'll be introducing Opcenter APS and LSI. I want to pause right there. Opcenter APS, formerly known as Preactor. The name change is still a little bit new to us, so you may hear Fraser and me as we talk without consciously realizing it, referring to it as Preactor. So if we do, we haven't changed products or anything. We are just talking about Opcenter APS, which is the new branding for Preactor. Then once I go through and do some slides there, introducing the packaging industry, some scheduling challenges, but we're going to jump into the presentation. Fraser's going to lead you through some basics, introduce you to the product, and then go into some more detailed stuff. So you can see the bullet points. These are the things that we're going to be addressing today. And then I have a bullet point for questions at the end. If you have questions as we go through this, please enter them into the chat window, and we will pause periodically and kind of catch up with questions. And then, as I say here, we will end with questions as well. Okay, so let's go ahead and get started. Talking about what packaging companies are dealing with, you've got a lot going on. It's not the way it used to be. I mean, the market has changed significantly. I know that when I started in packaging, there were still a lot of companies in the US who were making what I used to call t-shirt bags, but basically shopping bags like you get at Kroger, Publix, that kind of thing. Now, you don't see any of that in the US, very little of it. That stuff is all offshore somewhere, being produced by the billions and being done with razor-thin margins. And that is one of the biggest changes, as we're seeing a big move from long runs with a low mix to just the opposite, more SKUs, high mix, low volume. And that creates a lot of challenges when the market is calling for different products. Along with those products, then we have additional complexities that you have to deal with. All of these variables that you have to deal with, in addition to satisfying what it is that your customer wants and so forth, you've got changing products, but you also have environmental regulations, other regulations, considerations, technology changes, lots of complexity that just wasn't there, even a couple of years ago. There's just been an explosion of complexity that you have to deal with. And then dealing with all of this with pretty limited resources, actually, expensive solutions to these expensive problems created by these complexities. So you have limited resources. You want to be sure that you spend that money wisely and that you spend it on things that are going to resolve the problems that you have. And then customers. We love our customers. They are the reason we exist, but at the same time, they can be pretty demanding, and those demands are constantly changing because they're being driven by their customers as well. And so there's a race to meet those customers where they are. And I think the key takeaway here is that if you won't, your competition will. That customer demand is going to be there and it's going to continue to increase. And so with all of these complexities and changes and managing all these things, we need to be able to act and to react to all of this in a way that is flexible and fast. To react to the unpredictability and the changes that you know of, and to be able to do that quickly and flexibly is so important. But even more so, to be able to react to all of the unpredictability and things that you never saw coming, like COVID, right? Who could have really imagined how quickly that would have come down and changed everything and just turned everything on its head very quickly, very fast. So these are the kinds of things that packaging companies are having to deal with. And that has an impact then on how you schedule, which of course has everything in the world to do with how efficient your production is. So to drive into a little more detail, common packaging industry scheduling related issues that we find. Right at the top of the list, late orders. Dealing with late orders is just, it's a killer. I mean, you cannot have a high amount of late orders and keep your customers. Not having a visibility to your backlog, taking a pretty good guess, working with standard lead times, things like that, but really not really sure how much work do you actually have and what's it going to take to get that done. So what a lot of people will do is throw overtime in a situation. But wouldn't it, I mean, you can do that, but how often have you spent on overtime, bring all the crews in on a weekend, and then on Monday morning evaluate things and say, wow, we didn't get as much as I thought, get done as much as I thought we did, or it didn't solve the problems we were trying to get to. And so these are the kinds of things that can lead to losing clients due to poor customer service. And that's a horrible thing to happen. I mean, you work so hard to get those clients in the first place, to then turn around and lose them is just tragic when that happens. And having chaos and confusion by not having the visibility, by not knowing where you're going, is kind of like driving blind, and it's not a good way to run a business. And so in order to make up for late orders and some of this confusion and chaos, typically a lot of companies will spend extra on freight to get things out quickly, right? To pay to ship that pallet by FedEx somewhere. Doing something like that can wipe the profits from a job that you have worked hard on for months. Losing business due to long lead times, excessive setups, creating inefficiencies. We all know these problems well. And, being able to expand, realizing that you need more capacity and being able to do that, but then with those limited resources, you don't want to just massively increase your overhead on the gamble that you're going to be able to bring in enough work and get all of that done. And so that ties in with not being able to model the impact of adding new equipment, tooling, labor, those types of things. So all of these things combined create a pretty tough situation. So let's talk about the possibilities. I kind of dragged you guys down into the funk with me there about all these problems. So let's turn around and look and say, well, what are the possibilities? What could things be like? What could happen as opposed to these things that we're dealing with over here? What if we could provide accurate lead times to our customers and know that they were actually accurate, that they could count on that? Increasing the visibility of your orders in the supply chain that feeds your production. Knowing your finite capacity of every line, every location. You have limited capacity to know what that is and know accurately exactly what it is you're dealing with. To be able to reduce changeover times drastically in a way that is just so noticeable, that is immediately noticeable. Decreasing waste, increasing your efficiencies, increasing your throughput, essentially. And then being able to take all of that great information that your ERP system is giving you and all that it does for you and magnify that and be able to have that information be that much more valuable because of all of the accuracy around your manufacturing processes. Being able to track your individual job performance is a very important thing to do, and being able to simulate what-if scenarios in order to aid major purchasing decisions. Like I was talking about, being able to model the impact of adding new equipment or tooling or labor, or what if we could model doing overtime before we ever spend a dime on it and see what the impact of that would be. Being able to do this what if without ever spending a dime is a huge, huge benefit to be able to have. And basically, to be able to consistently produce realistic schedules that can be followed and relied upon. These are the possibilities. These are the possibilities. And the answer to this is an APS system, Advanced Planning and Scheduling. So why APS? I mean, what is it that I'm saying this is a solution to these scheduling problems, and yet I make some pretty bold claims about it? So APS is the tool that is going to help you optimize the things that define value for your company. So in buzzword terms, these are value drivers. So your company is defined by these types of things, right? The value, the quality, to be known for your quality adds a tremendous amount of value to your products and to your company. You have all of these assets, and you want to be able to use them, not collecting dust, but getting the most out of them. Sweat those assets and make sure that you can get everything out of them that you possibly can. Being able to get to market faster and sooner than your competition, that's huge for your customers. And being able to get the most out of the labor and employees that you have while at the same time taking care of them. They're your most valuable asset. So you want to be sure that they're happy with the work that you're putting in front of them to do. And you also want them to be as efficient as they possibly can be. And then the whole issue of inventories, whether it's raw material, finished goods, or work in process, you want to have the right inventory levels to meet the demand when they're needed and where they're needed. So the way then that APS can help you increase this value is through some of these things that I've listed here. Increasing the utilization of your resources and your tooling, being able to identify a bottleneck before it becomes a problem, before it causes chaos out in the plant. Find those bottlenecks ahead of time, get them resolved so that your throughput is consistent and smooth. Fast and frequent rescheduling to deal with the bazillion different things that can come along and screw up your production. You want to be able to react quickly and accurately to those types of things, those types of problems. Reducing your WIP so that it's not all piling up somewhere where your other assets are starving to be fed. And then raw material inventory reduction, again, having the materials that you need, where you need them, when you need them, but not carrying such a high amount that it's costing you money to do so. So all of these things lead to a bottom line of improved communication, not just internal communications, but external communications with your customers and your suppliers. Improved customer service, you know the value of that. I don't have to elaborate on that. And improved productivity, reduced waste, increased throughput. All of these things ultimately lead to increased profitability for you. So this is why APS. APS can help you get to this increased profitability by optimizing these value drivers for your company. And these are the ways that it can help you do that. So we're going to be talking today about what APS is. And in order to set that up, to set up the contrast, I want to take a moment and talk about what APS is not. Because there's a lot of scheduling solutions out there. There's a lot of different types of scheduling that are different ways that you can approach scheduling. So just the three top ones that come to mind. Oh yeah, magnetic boards. I did that. I put that up there. I have personal experience. I worked as a scheduler for 5 years in a manufacturing plant, in a bag plant, in fact. We printed and converted all different types of bags. And I had an office that 3 of the 4 walls were magnetic boards. And I had markers and tags and colors and sticky notes and everything else in the world on that magnetic board. And yeah, I could line up a schedule, but it was not easy. The synchronization, timing, managing all those things was just an absolute nightmare. And if something changed, you just pretty much have to start at the top and start figuring it out all over again. ERP, MRP, right? So you've got an ERP system, and maybe it has an MRP component to it. And so that often is touted as being a scheduling solution, but it is not a scheduling solution. And the reason for that is it's not giving you a real simulation of what's out there on your shop floor. It's not going to simulate true finite capacity on your shop floor. It's going to schedule things into buckets of time. So, and that's it. So for instance, if I have a week of orders that come in and they're due tomorrow, MRP is going to say, okay, hey, you've got a week's worth of orders due tomorrow, so you better get cracking and get started a week ago because it's due tomorrow. Well, that's not realistic. That's not giving you anything that you can possibly work with. And then spreadsheets. I mean, most of the world, I hate to admit, is on spreadsheets right now. That seems to be the solution that everybody goes to. And you can do a lot with spreadsheets. I won't completely dismiss them because there is a lot of good that you can do with them. But they're still not going to give you a true picture of your capacity with the constraints, the capacity constraints, your materials, your labor, your tooling, and all of the complex sequencing that you may be doing, and synchronizing multiple operations and taking into account all of these other factors. Trying to get this all done on a spreadsheet, it's a pretty tall order. And with all of these tools, magnetic boards, spreadsheets, the ERP, MRP, they're all familiar, they're well used, but they cannot simulate your real world capacity. Constraints that you have, the rapidly changing situations. I think about the years that I worked without an APS system as a scheduler, and, could easily spend 8 hours making a schedule. And by the time I'm done, changes had occurred that rendered parts of that schedule obsolete before I was even done with it. Or at least I would do a schedule and the first big unexpected change occurs and it would take hours to fix it. It would just take hours to remediate something like that. In some cases, having multiple people out running around the warehouse and the plant looking for materials. What can we do to try to pull stuff in and get ahead? So that's not an advanced planning and scheduling system. These are solutions that people bring to bear, but they're not going to get you what a true APS is going to get you. So today, our focus is going to be Opcenter APS. So let's talk about that a little bit, and then we'll lead into a demo, and you get a look at all of the things that we're talking about here. So in this slide, I've got a few different things going on. If you look on the left-hand side, I'm going to talk about Opcenter APS. It's the largest installed base of any independent planning scheduling software company for manufacturing worldwide. Over 6,500 companies use it, over 10,000 licenses have been shipped. And in North America, there have been nearly 350 companies or so that have purchased Opcenter as well. Looking over on the right-hand side at those images, Opcenter APS is made up of two components, scheduling, which we're going to be focusing on today, and planning, which we're not going to be focusing on today, but I will address the difference between the two in just a moment. In the center, then, you can see we have a whole bunch of logos, different companies around the world and the industries that they come from that are all using Opcenter. And this is a real testament to the flexibility of this product, because basically it's the same core product that has been put into all of these different industries, these big companies, and it's doing the work for them basically through configuration. And so we'll talk about that and how that's done in a moment. Lean Scheduling International, the company that we all are from, has been delivering the APS solutions over 25 years, and in North America, we have the largest installed base of any partner. So we've got about 80% of all the Opcenter APS in North America are customers of ours. So we've been around. We've got we have people on staff who have been doing this over 20 years, just like Fraser. We have a lot of skill and experience. We have a methodology for implementation that has been refined through hundreds of implementations. So we'd be glad to talk to you more about that, what we can offer, and some details about our company as well. So we have customers in the packaging industry. These are some of our customers. In fact, I haven't taken a look at who's on today, but some of you may even be from some of these companies. It's very possible. So if you are, welcome. We're glad to have you. And if you're not, we'd love to add your logo to this page sometime. So let's see what we can show you today that might pique your interest. Okay. So as far as Opcenter APS, how it fits, how it interacts with your ERP system, I mean, what is the deal here? So basically, it's going to sit in relation to your ERP system in such a way that we're integrated to the ERP. The ERP is passing orders, bills, materials, routes, product information, in some cases, down to the schedule, where the schedule is also taking in, can be integrated to other systems, preventative maintenance, manufacturing execution systems, shop floor data collection, that type of thing. Pulling all of that into the schedule, working the best possible scenario as realistically as possible, and pushing the results back up to the ERP. That is the most typical way that this is laid out and configured. Then the product itself. The reason that this can fit into all of those different industries that I just talked about a few moments ago is the fact that it has this core that is this powerful APS engine, and none of the partners, not us nor anyone else in the world, can touch that core. Only the people at Siemens who own the software can do that. And then on the outside, we have what's called a modeling layer. And the modeling layer is the method that we use to integrate, to do the integration and to configure this in a way that is going to directly get to the problems that we're trying to solve with the APS. So just kind of looking around the wheel here in the top left, scheduling rules, material control rules, etc., that type of thing, data import, export, all of that is done through scripts. So scripts are a mechanism to talk to the outside world, if you will. And then below that, we've got the user DLLs. This could be custom code to access the API and essentially, do what it is we're trying to get to. An example of that could be if I'm dragging an operation from one line to another, to have it adjust the scrap rate on the fly dynamically in real time. Those are the types of things that we can do, but it takes a little extra code to do it. And if it's something that you need to have done, we have the tool set to get that done and the skill to do it as well. On the top right-hand side, that TRTDF is for table definition files. And this is essentially where we're able to define every table. We can add or modify tables, incorporate staging tables, and so forth. So we're able to control the table structure that sits outside of the APS core. And then finally, we're able to have it, each user can have a unique experience through the means we have of making the menus and the objects that they're in the interface be unique for different users. So this is the core of it. And one big takeaway I'd like you to take away from this is that upgrades are extremely simple because of this. The years that I spent implementing ERP software, an upgrade could take weeks or months, but take a really long time to do an upgrade. Whereas here, an upgrade, maybe half a day. And that's because that core gets upgraded and it's just basically take out the old, put in the new, test it to make sure all the links are still good, and you're pretty much good to go. So it's not a huge, big, dangerous thing to do an upgrade. Siemens does a couple upgrades every year. Okay, so I promised you a real quick comparison of planning and scheduling just to make it clear what I'm talking about, because people do use the terminology differently. A lot of times people will say planning when they're referring to what we actually refer to as scheduling. So this is how we make that distinction. Planning being what to make, when to make it, how much, and where to make it, as well as the materials and resources that are required to do so. That's the plan. And then scheduling says we're going to take that plan, and now how's the best way to do it? How are we going to execute that in the most efficient manner? And that comes down to the sequencing, keeping things synchronized, different operations synchronized, the priorities, constraints, conflicts, all of that. Being able to react quickly. Scheduling is the tool for that. And then planning, of course, is the broader rough cut take on all of that. Okay, so that's the difference there. I will just leave it at this. As far as planning goes, if there's any interest or if you think you might have a need for planning, we can talk about it. Just please get in touch with us. I'll be happy to get you some information on that. Okay, so sequencing is the thing now that I'm really going to dial in on, and then we'll move on. So sequencing, especially in print, is really important. So I kind of put up there sort of almost tongue-in-cheek, you know, how difficult can it really be? I mean, it's what schedulers do, right? You just line things up and that's that. So I did a couple of little exercise here just to give you an idea of what that complexity can look like. So we have these 5 objects, and so the question is, if you look at that, how many different combinations do you think that those 5 objects, you know, the colors, the numbers, and everything could come together and make? How many possible combinations? I don't know, 5 times 5, 25, something like that maybe. Well, actually, it's 120 different combinations that it would take to do this. So that's just 5 little objects. So let's double that. If we double that, what does that look like? Are we now talking about 240 because the one before was 120? Actually, what we're talking about here now is 14,400 different combinations with this simple example. Now, take that and extrapolate that out into your plant. All of the many lines that you have, the many presses, the finishing equipment that you have, all of that and all of the possible combinations of all of those jobs with multiple steps, depending on the complexity of your routings, it can get really tricky. And then on top of that, you need to consider all of the constraints, the material constraints, the tooling, the labor. Honestly, by the time you have to deal with all, the schedule is almost nearly impossible to manage. And so how could you possibly manage all of this with spreadsheets or a magnetic board or even an MRP system that is only going to give you buckets to work with? How can you do that? The complexity is so intense. You really need an APS system to manage all this, and you'd be surprised how quickly and efficiently it can be done. Okay. So, dialing in now in detail. These are the things that we're really going to talk about today. Sequencing colors at the press, also taking into account substrates, repeat, raw material availability and labor, your labor, your pool of labor, the availability, different kinds of operators, etc. Resolving cylinder tooling conflicts, wave scheduling, some of the different ways that we can schedule to get to the results that you want. And also scheduling finishing operations. I wanted to include this today and address that because I have been in so many printing plants over the last 20-some years that don't schedule their finishing operations. They schedule their presses and then leave it up to the operators to make the best call on, well, the whip's here, so let's go ahead and get it done. Well, that's the last step before it goes out the door to your customer. That really should be scheduled as well so that you know exactly when that's going to be done, exactly when it's going to be ready. So I wanted to include that as well. Okay, so the last note before we jump in to the demo. The packaging industry is really broader than what we're going to address today. We're going to be using a model that is flexible packaging, bag, pouch, label, sleeve, that type of packaging. But we recognize that there is just as many companies out there doing folding carton, rigid box, corrugated boxes and displays, cans, and glass containers. And I just wanted to assure you, we have experience, we have models, we can absolutely show you your industry. If you're not in flexible, but you're in one of these others, we can absolutely show you give you a presentation, possibly even use some of your own data to show to you and get you an idea what we can do. Okay. I've talked quite a bit, so at this point, I'm going to stop and stop sharing and invite Fraser to take over and begin sharing the software.
Okay, thanks, Hans. Whoops, share screen, there we go. All right, can you see my screen?
Yes.
Yes, okay, great. All right, so let's dive in. So what I have here is a flexible packaging model. And we're going to go through a little bit of the underpinnings of how it's built. We're simulating bringing things in from an ERP system. Then we're going to go into the schedule and look at some different options for sequencing with all those attributes that Hans just mentioned. But first of all, let's take a look underneath at how this kind of thing is built here. So as Hans mentioned initially, we're a simulation of your production environment. So we basically do that by simulating your machines and the products and all the things that go into having your production environment. So the resources themselves, this is what we're going to actually schedule our jobs on. So you can actually follow how the sequence here is going to go. You've got prep, you've got some printing machines, slit, seamers, and then rewind at the end. So we have basically a very simple flow here. So these are our resources, but you'll notice here I have a changeover group. And changeover group is essentially a way that we allow Opcenter to figure out when you're changing a product, a color, a material. That usually means that there's some kind of setup or cleanup that has to happen. And rather than trying to figure out how to put all that data into the system, we're going to actually let Opcenter figure out what that changeover actually entails. So if you look over here on the right-hand side, this is part of that modeling layer that Hans talked about, where we've got some additional tables. So we have attributes like color, some materials, we've got repeats, we've got slit width, core size. All of the attributes that make sense to your particular environment are here. And one area or another, a change in one of these attributes is going to incur some setup time. So we actually use, in this case, we're going to use a matrix of setup times. If we look at for example, converting has one value here. When repeat changes, we're going to insert 20 minutes. Very simple example. If we look at printing, though, it's a little more complex because printing actually has a couple of different attributes that contribute to changeover. So the first one is color. So we'll take a look at color. It's got 3 different color combinations. This column here, when you go from this particular color to another color, in this case, if you go from this one to this one, we're going to insert 1 hour. That's changeover, cleanup, whatever it happens has to happen to basically change over that printing machine for the next product. So that's one. We also have a material matrix. So when the material changes, we're putting in another changeover time. So if you notice this one, from this one to this one, exactly the same attribute. So there's no change. But when you go to this one, there's 30 minutes. So that's the second one. And we also have, I believe, repeat as another matrix. So these are all additive in this case. So when if all of these 3 things were going to change all at the same time, then you're going to have a serious changeover. So we have to try and minimize those kind of changeovers. So we have our attributes, we have our resources. This one also has some secondary constraints to keep in mind. So we actually are going to model our labor. We got basically just 2 operators just to play with. We've got 3 here. We have an inspector. So we're going to assign these pieces, these labor pieces, to certain operations so that we can say, yes, we've got a job that needs to go to print. We have a printing machine that's available, but do we also have an available operator? We have to make sure that we have that also. So we have all that. And again, I'm mentioning that we are pulling from an ERP system. So we will have some supplies. We've got raw material stocks. We have purchase orders coming in. We have our actual work orders that we're going to be scheduling. We've got the bill of material links between all these. So we basically got everything we need to go ahead and start scheduling. So I will jump into the schedule and we'll take a little look at a little real estate explanation here. Standard Gantt chart. These again are those machines that we are going to be scheduling. Here's all my jobs that need to be sequenced. There's another view of them all here. And then we've got some KPIs down here. The ones we're going to be looking at here is on-time deliveries and setup time. As I mentioned, we're going to try and minimize those setup times. So the first sequencing there's lots of different ways to sequence. So I'm going to just start off with one of the very basic ones, which is a forward sequence by due date. So this would be typically the only kind of sequencing you would get from an ERP bundled scheduling model. So we'll just go ahead and do forwards by due date and we'll see what happens. Okay, I have got colors turned on here, so you can see my colors are essentially all over the place. Wherever you see the little black bar in the middle, that is representative of a changeover time. And as I was talking about, changing in colors, we go from whatever that first color option there is to this pink one, that's the color change. We probably also have a material change. We have a material change here. So we've got that. And we probably also have the repeat change. So we got repeat changes there. So the way that I scheduled was forwards by due date, which basically means we ignored all of these attributes and just looked at due date. And if you look at the KPIs, we're great. We're 100% on time. But if you look at setup, we have 300 hours of setup. So we're going to have to do something about that. Couple other things to check out here. When I highlight jobs, you can see how the jobs are sequencing. These are the 4 operational sequences for this particular job. You can also see a little dotted line connecting up here, and that is connecting to the raw materials. So I can actually show the raw material explorer, which allows you to look at the way this job is built. We've got our operation sequences. We're fulfilling our sales order, but we're pulling 2 items from our stock information. So these are our raw materials. So we've got everything linked. So we're not basically, we're not trying to tell the guys on the floor to start working something if you don't have all the raw materials available. And that goes back to Hans's point of having a real schedule you can actually follow. And you don't have to worry about is it actually valid. Of course, when Opcenter is scheduled, you do have the ability to move things around. So if you decided that you did not want to put that job there, you wanted to drag it to this other machine, you can do that. Certain cases, if you try and drag jobs in the wrong place, you will get these kind of errors. There's not really an error. What it's just saying is when Opcenter ran the schedule, it took into account all the logic that we put in, including all the constraints that we put in. Me doing something manually just violated one of those constraints. I'm using too many print operators if I want to. So I'm just going to say yes real briefly, and I don't want to undo it. If I take a look now at my plot of operators and users, you can see here's that print operator. I violated that. I said, you need 2 there. Okay, so normally we're not going to violate that sort of stuff. We're just going to let Opcenter schedule properly. So let's go back here. We will take a snapshot of our KPI. Now that I've done setup time, scheduling by due date only, I'm now going to try a different approach. Let's take all of our jobs off. And this is part of that what if scenario stuff that Hans mentioned, because you can do all this as many times as you want, trying to find, what is your optimum way of scheduling. This time, I'm going to go completely the other way, and I'm going to run something called an APS rule called minimize overall setup. This one is going to ignore due dates and only find a way to minimize that overall setup time. So this guy will run, and you'll see as soon as the colors come up, and it does take a little bit longer because there's more decisions to make, you can see it's done a great job of putting all the colors together as much as possible. If I clip back over here to the material, whoops, color again, there's material, it's done the same thing there. So it's pretty much ignored the due date and just said, I've got to minimize setup time. If you look at my KPI for setup time now, I've gone from 300 hours down to 36. Well, that sounds really good until you look at the on-time delivery. I've dropped to 74%. Obviously, that's not good enough, but at least I've now bounded my problem. I know colors are a big deal, and I know due dates are a big deal. So somewhere in between is probably my answer. Now, again, what ifs? I'm actually going to look at a different rule now called the weighted rule. The weighted rule allows you to apply preferences, essentially, to attributes. This table attribute 2, that's color, and there's my due date. I'm going to put some on there. This one here is material, this one's repeat. I'm just going to use those 2 for now and just see what happens, see what's different. We'll sequence forwards by weight. Okay, it did a fairly good job. On-time delivery is up to 83%. Setup time is up to 110 hours. So we're still 200 hours less. 83%, no, I would say that's still not good enough. So one of the other options that we have is something called a preferred sequence rule. This one is actually set up quite differently. The preferred sequence rule is set up with 3 parameters built in. One is color, the next one is material, and the next one is repeat. And it automatically does it, so I don't have to worry about setting weights or anything like that. It's just going to run. And again, I didn't say this yet, but there's nothing customized in this model. This is all standard Opcenter stuff. The only changes I've made is those attribute tables. There's no custom code. This is all kind of built-in stuff here. So I'll let the preferred sequence model. These APS rules take a few seconds longer because there's a lot more to do. And you can see now that getting those 3 attributes correct, I'm back up to 100% on time. And my setup is, to get that, I need to have set up at 206 hours, 201 hours. So I've still, from my basic forward scheduling, I've still minimized, pulled out 100 hours of setup time in there, but I am meeting all my due dates. So those particular attributes are specific to, to your industry. We build those into a model, and that gives us the way to sequence and come up with essentially an optimum schedule based on that. So I will pause there. And Chris, are there any questions yet?
Yes, we do have a couple questions. I would like to just add what you're seeing down there at the bottom, snapshot. That is a tool that we've developed to assist with some what-if analysis and to do comparisons. If you don't have snapshot in your Preactor model, your Opcenter model, and it's something you're interested in, reach out to me after this. We can talk about that. All right, that's enough of that. Let's get to the questions. The first thing, Fraser, for you is how do you get production from the how do you get feedback from the production floor as things change?
Good question. Good question. Yeah. So when I actually run this schedule, this is my plan. Okay. And until I get feedback from the production floor, it's really just a plan. So I'm not set up to do it, but I'll show you essentially where the data goes. We take a look at any one of these orders. We've got, first of all, the predicted setup, start time, and end time. So if you have an MES system, we can feed that into here based on the order. So if the job is started or finished or whatever, we can feed that information into here. We also have something called a mid-batch time. So this would give you a way to say, okay, the job is 8 hours long. Okay, we're halfway through. We were supposed to make 3,000 feet of this, but we've only made 800 feet. So you'd be behind schedule. So essentially, we end up with a time. We end up with a quantity. This is not going to work. I'm not going to actually do it. But that basically gives us feedback as to whether we are behind schedule or ahead of schedule. And then you can use that information to sort of repair your schedule, get it set back into where it should be. Typically, the way it happens is, your scheduler will log into Preactor. I did it. There we go. Got one. We'll log into Opcenter. And the first thing they do, they will connect to their ERP system and download all the changes, all the new orders. If you have an MES system, it'll feed that information into here automatically. And then essentially the first thing you do is you reset your schedule. So you're now exactly linked up with what the MES system says as far as feedback and your ERP system as far as orders.
Excellent.
So good, excellent question.
Good explanation there. Moving along to the second question that we've got here. How do you take a machine down for maintenance?
Yeah, also a good question. If you actually had a maintenance system, you could feed the data in, you'd be one of the few. We've never actually, I don't think I've ever had anybody be able to do that. But essentially, all of the machines exist on a calendar. So if you essentially take the data that we would get from a system to say, hey, this machine's down, what you're actually doing is editing the calendar of that machine and putting it in a certain state. So I always say breakdown on this one. I'm in demo mode here, so I will put it down for, let's say, 5 days. Serious breakdown. And as soon as I click, that'd be bad. As soon as I click OK, you'll see a breakdown state appear on the machine. Basically, the way I put it, it just pushed every order out. Okay, so all these orders are going to be delayed because I have a breakdown. Then you can essentially say to yourself, well, what do I want to do? Typically, you would put in like a freeze zone like this. What that does is freeze these orders that are already sequenced. Then I would pull everything off the board that hasn't started, and then whatever sequencing logic I wanted to use, I would use again and let everything reset itself and put it back on the schedule. You can drag these jobs to other machines. There's all kinds of options, but automatically doing it like that is probably the best option. So again, all the machines exist on a calendar. A breakdown or any change to the status of a machine just affects that calendar, and whether we do it manually or we get some data from a feed, we'll do it that way.
Very good. Very good. Thank you, Fraser. We've got one more question. We have about 15 minutes left today as I ask this third question that we've got here, and it is how can you take into account cylinder or tooling constraints?
Right. I'm going to actually turn this one back to Hans.
Yeah.
My model only deals with operators. Okay. Hans's model has more information, so I'll stop sharing and he can take over.
Great. I was just going to suggest that, so you beat me to it.
There you go.
All right. This should look familiar to what pretty much the same model that Fraser's working with, but it's slightly different and made some changes to it. So we're looking at a view here where I've just isolated my presses. You'll see a different view shortly, but I've just isolated all my presses here. And down here, I have what I have representing is all of my cylinders. So I have 9-inch cylinders, 10-inch cylinders, and so forth. So we can see the cylinders that I have. And basically what we see here is that I have a certain number of each of these cylinders, but because I scheduled this and I told it to ignore all of my secondary constraints, basically just ignore the fact that I have a limited number of cylinders to work with. Give me the most efficient schedule you possibly can. It says, okay, I will. And then this red highlights where, okay, so we've got cylinder conflicts. I have 2 different orders calling for this same cylinder right here, right? So that's not really tenable. You know, we need to figure out how we're going to do that. So I can scroll across and see all of the jobs that are calling for these cylinders. And as I pointed out, I clearly have some cylinder conflicts, which we can see indicated in red. I've got quite a few of them going on. So a lot of different ways to take that into account, but really the primary one is just don't disable the secondary constraints in the first place when you run it, and it will honor the fact that you only have those. But if you want to see, to do kind of a what if, well, what would it look like? I mean, do I consistently need more cylinders? Is this something that I could use to make a decision to buy some more cylinders? Well, I'd have some hard facts to work with to know how often I'm having these conflicts like this. So what I've done is I'm just going to go ahead and re-enable those secondary constraints. And then we just have a little tool here called a repair schedule. And what that repair schedule will do is we'll just go through and fix things. And basically, you notice it kind of spreads some jobs out so that now at no point do we have any of these cylinders in conflict, right? You're able to see that it's carefully placed all of these and move the jobs out in such a way that we never have to, you know, have a situation where we're calling, 2 machines are calling for 1 set of cylinders. Now, if, you know, honestly, in real world, we would also work in some time for stripping and prepping those cylinders to go on to the next job. But this is just an example to show you how quickly and easily you can maintain those cylinder conflicts. So it really would look like this with a little additional time in there to manage the stripping and mounting process that you would need to do before going on to those cylinders. Okay, so Fraser gave me a nice segue into this, or that question did actually. And I did want to show those cylinders. So there was something else here that I wanted to address as well. And I'm going to change my view. I'm going to go back to the full view, more similar to what you just saw Fraser looking with. And I'll just say, yeah, go ahead and set up snapshot. So now I have the schedule in front of me here. And when I used to schedule, I would schedule my presses first. And then I would go on down to the finishing equipment and do, you know, 1 set of finishing equipment first and then go and do another set. I would do my wicketers, I'd do my flatbeds, that kind of thing like that. So in this case, this tool will allow you to do that kind of work if you so choose to do that. So I just wanted to show you, and it's what we're calling wave scheduling. All right. So I'm going to take everything off the board right now. And I'm going to shift over to the editor view where I can see all of the jobs that I have here. And if you'll notice, we've maintained these colors that I have highlighted over here. So we can look at all this and say, okay, so we basically have these color gamuts. And so what this allows me to do is I'm going to say, well, I want to schedule these first. This could also be that I'm scheduling, say, an operation, and I just want to do the printing operation first or something like that. But for simplicity today, I'm just going to go ahead and stay with the colors. So basically, I'm saying I want to highlight all of that color set. And when I do that, you'll notice these others dim out, and only the ones that I highlighted are, are showing, right? So I come back out here and say, now what I want to do is to go ahead and schedule. And when I let that rip and go, you see it did all of the green ones. And then I can just go ahead and follow that and say, now I want to do all of the red ones, and then follow that with all of the blue ones. And so that's the way that we can do that. And again, I could do that with press, followed by slitting, followed by, whatever the steps are, whatever your processes are. This is a tool that allows you to go ahead and do that. Now, the last one is doing a lot more work here because it has a lot of openings in other places to find where it can fit those in and get that work done. But the bottom line, the net result is that we've been able to group things in such a way that I was able to do it in waves and address it that way. The other thing about that we can do that I didn't include in this model is you could have a customer. So you would be able to have one customer, like if you have one big customer, Lowe's is your customer, or Home Depot or something like that, and you want to be able to make sure that their work is always scheduled and on time. Well, you select those and do those first, and then schedule everything else around it. So there's a lot of flexibility, a lot of ways that you can work with this beyond the drag and drop, certainly beyond even the advanced scheduling rules. There's a number of different ways that you can take advantage of this and do some what if work and planning and prioritizing of orders and so forth. Okay. I talked about finishing equipment. I just wanted to emphasize that if we just let the schedule do its thing, like Fraser showed you, we are scheduling the presses. We're making sure that our most expensive assets that can never be down are going to be running in the most efficient way possible. But then at the same time, it's doing the work of scheduling those. It's scheduling everything downstream as well, so that we know that everything is always going to be synchronized and things are never going to, are going to not be synchronized, or the materials won't be here. All of those things are taken into consideration when we're doing this. So the finishing operations, we're making sure that the WIP will be available to start those operations at the right time. Another note on this that I wanted to point out, oftentimes I had really, the rush job that I had to get through. As soon as I got 2 rolls off the press, get them to the bag machine and get going. Well, that press, that job was due to run for 2 days, but as soon as I got those first 2 rolls off, we were going to start converting and stay right on top of the press with the bag machines. So this will let you do that as well. In all of the synchronizing that we've been showing here, if I highlight just any random order, we can see that everything is pretty much ready just in time. But we can have that so that this would start as soon as we're just slightly into this job. And when we are able to do that, it's called a transfer quantity, where we're able to identify either a quantity or a percentage of completion, after which we can begin the next operation. So it does take that into account as well. Okay, so the last thing before we pause and see if there are any more questions is I just wanted to point out there's lots of reporting. We deliver this with, 34, 35 standard reports, and then what people do is modify these reports. So just a real simple one, I could do one that's called, a work to list by resource, for instance. So maybe I'll just go ahead and run that report. We can have a look and see what that looks like. Basically, it's just a real simple SQL reporting services report, and you're able to print it here and then send it out to a printer, export it. But also, these can be delivered to out to the shop floor, to a tablet, or to an MES system. It's not limited to just printing some kind of a paper report. There's a lot of flexibility. All of our customers take these reports, start with the basics, modify them somewhat to suit them to what they need, and then they're able to go. So in the example of the one I just brought up, you can take this directly to any of your machines and say, okay, guys, here it is. Follow the schedule. This is when you should be starting. That's when you should be ending. And, you're going to have all the materials, all the WIP, whatever it is you need, the tooling, all that's going to be available at the time that you need it. Okay, so I'm going to stop with that, pass it back to Chris, and you can go from there.
Yeah, and we've got just a few minutes here, so I'm not sure that we'll actually have time to show this, but we do have a question that's can I schedule by multiple attributes like a size within color? So
Yes.
I'm not sure that you actually have time to show it, but you may just be able to talk through that a bit.
Yeah, it's very much like that final sequence I ran in my model, the preferred sequence. It had 3 attributes that were concerned with the way it's sequenced, and you can have as many as you want.
Very good.
And those
Very
are,
good.
and those are attributes. Those are attributes that come down from the ERP system. They define your product.
Actually, not always, because usually most ERP systems don't necessarily have all of those attributes. Because I think I had 9 different. And most ERP systems usually have, a couple of unused user fields that you can use, maybe 5. If you need more than that, what we'll do is we'll make a hybrid inside Opcenter. You can maintain that specific data that's not in your ERP inside Opcenter, and we merge the 2.
Excellent. Well, I stand corrected. Thank you.
Great. And that was great participation. Fraser, Hans, you both did an excellent job today bringing the material, and that was great participation by all of the attendees. Good questions that we had. We certainly appreciate all of you joining us today and hope that you've been able to take away some valuable insight and information about the ways that Opcenter APS can benefit those of you in packaging. If you have additional questions or you want a more personalized demo, feel free to reach out to us by using the contact information that's now on your screen. And we're going to leave this up for another minute or so, but we'd love the opportunity to learn more about you and provide you with any additional info that you may need. Have a great rest of your day. We look forward to connecting with you again soon. Thank you.